Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma నుంచి స్టార్ట్ అయిపోయినాయి, సెకండ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది, థర్డ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది. 3 years కోర్స్ ఉంటుంది, 2 years కోర్స్ ఉంటుంది, 1 year కోర్స్ ఉంటుంది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో సాయిమేధ కోటి హైదరాబాద్ ఈస్ ప్రొవైడింగ్ ఎవ్రీ ఇయర్ కోచింగ్. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై సాయిమేధ కోటి హైదరాబాద్ ఓన్లీ. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. Effective coaching ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Hello everyone, welcome to Saimedha Koti Hyderabad. In this session I would like to discuss about previous year questions of Ecet in the concept of armature reaction and commutation of the DC machine. Let's start from the question number 1. The question 1 is, a DC machine is fitted with the both interpole winding and compensating winding with respect to armature circuit. Option 1, the both interpole winding and compensating winding are in series. The both interpole winding and compensating winding are in parallel. The interpole winding is in parallel and compensating winding is in series. Interpole winding is in series and compensating winding is in parallel. So let's talk about initially compensating winding. Compensating winding is placed in the pole shoe which is connected in series with the armature winding. So to neutralize the armature flux. Okay, similarly the interpole windings are placed along the quadrature axis and this winding is connected in series with the armature winding. So to neutralize armature flux. So this answer for this question, option 1 is correct. So both interpole winding and compensating windings are connected in series with the armature winding. So next question number 2, the demagnetizing flux in the DC generator. The DC generator, option 1 increases flux EMF, the decreases EMF, increases speed and the decreases the speed. The demagnetizing means, let assume, suppose we have so this one is the main field flux lines, all the main field flux lines are passing from. So assume this one is the main field flux phi f and armature flux lines Okay, assume this is a all are armature flux lines. So here we have a armature flux. So in this case, so whenever armature flux opposes main field flux, so the resultant flux in the machine decreases. So this effect is known as the demagnetizing effect. It causes reduction in the generated voltage in a generator and torque in case of the motor. So now what about the resultant flux in the machine? The phi resultant is equal to the phi f minus phi a. So this is the phi f, the minus the phi. Resultant flux phi f is equal to field flux minus R. So what we know that generated EMF in the generator, the EZ is a directly proportional to the phi resultant and the speed of product of the phi resultant and. So now this is the speed is a constant, but the decrement in this resultant flux. So what will happen? The decreases in the resultant flux, the decrease as the generated voltage of the generator. So that what is the answer for this question? Option the 2 is correct for this question. And next one, question number 3. In the DC machine is provided with the interpoles and compensating winding. These are connected dash with the armature winding. Option 1 parallel, option 2 series, option 3 interpoles in series and compensating winding in parallel, and option 4 interpoles in parallel and compensating winding in series. Okay, interpole winding and both interpole winding and compensating windings are connected in series in order to neutralize the armature flux in the machine. So that answer for this question, okay, option the 2 is correct. Both are connected in series with the armature winding. And next one, question number 4, interpoles helps the commutation in the DC machine by cancelling armature reaction MMF, aiding the main poles by causing the statically induced EMF in the coil undergoing commutation, by causing dynamical induced EMF in the coils. So in the coils undergoing commutation. So now here interpoles, okay, commutation in the DC machine. So by causing the statically induced EMF in the coils undergoing commutation. Suppose first option, see the first option here, cancelling the armature reaction MMF. So this is not correct. And aiding the main poles, okay, it is also not correct. So now interpole winding. So these interpoles help the commutation in the DC machine by causing dynamical induced EMF in the coils undergoing commutation. So that option 4 is correct for this question. And the next one, the function of the interpoles in the DC machine is option 1 reduce the field winding heating, and option 2 improve commutation, and option 3 compensate for air gap variation, and option 4 reduces losses. The function of the interpoles in the DC machine: reduce the field winding heating, improve the commutation. So always interpoles are used in the DC machine to improve the commutation process. So that option the 2 is correct for this question. And next one, the question number 6, to have a sparkless commutation, armature reaction effect in the DC machine is neutralized by increasing the field excitation, the fix the brush axis in the alignment with the main pole axis, the shifting brush axis from the geometrical neutral axis to the magnetic neutral axis, the using compensating winding and commutating poles. So this the shifting the brush axis from the GNA to MNA is, you can reduce the spark, but you cannot get a sparkless commutation. So there is some disadvantages. So in order to overcome these disadvantages, some other methods are used to neutralize the armature reaction effect, such as the compensating winding and interpoles or commutating poles. So that option 4 is correct for this question. And next one, the question number 7, the demagnetizing component of the armature reaction in the DC generator. Option 1 reduces generated EMF, and option 2 increases armature speed, and option 3 reduces interpole flux density, and option 4 that results in the sparking trouble. So demagnetizing effect causes the reduction in the resultant flux in the machine, so due to which generated voltage of the generator will be decreased. So that answer for this question, option that 1 is correct, reduces generated EMF in the machine. And next one, question number 8, the armature reaction effect in the DC machine can be neutralized by using option 1 only compensating winding, only interpoles, the both compensating winding and interpoles, and main field winding. So now here armature reaction effect in the DC machine can be neutralized by using both the compensating winding and interpoles. Interpoles are also called compoles or commutating poles of the machine. So that option the 3 is correct for this question. And next let us solve question number 9. The purpose of using compensating winding in the DC generator is to option 1 reduces eddy current, and option 2 provide a path for cooling air, the neutralize the effect of cross magnetizing effect, and reduces hysteresis current. So main purpose of the compensating winding in the DC machine is to neutralize the armature reaction effect. So which armature reaction? Cross magnetizing effect of armature reaction. So that option the 3 is correct for this question. And next let us solve question number 10. In DC machine, the field flux and armature MMF axis are respectively along. So field axis and armature axis. So this one assume as, suppose this is the north pole, okay, this one is the south pole. Assume this one is the north pole of the machine and this is the south pole of the machine. Always flux lines are passing from north pole to the south pole. So this is the direction of the field flux, and there is a armature, okay, in this case assume this one is the armature, and armature conductors we have placing some amount of the armature conductors like so on. So now in this case cross mark, okay, here the conductor which are under the influence of the north pole, suppose if it is rotates in a clockwise direction, now conductors under the influence of the north pole have cross mark, and conductors under the influence of the south pole have dot mark. So due to which what will happen, suppose according to the right hand thumb rule, so if thumb indicates the current direction, the orientation of the fingers around these conductors that indicates the flux direction. Now this is a clockwise direction. Now next one, flux around this conductor, that is a anti-clockwise direction. So this flux is known as the armature flux. So if I draw this curve, suppose it is the x-axis and y-axis point of view. So now armature axis, okay, suppose, okay, this one is the field flux of the machine, the phi A, and armature axis, okay, this is the direction of armature axis. So suppose it is a positive group of the brush and negative group of the brushes, and this is assume positive and the negative. Armature flux lines are passing from positive group of the brushes to the negative group of the brushes. So now this one is a pi A. So now here this axis is known as D axis and this axis is a Q axis. So that so this field flux, the field flux along the direct axis and armature axis along interpolar axis. This is also called the interpolar axis. So that answer for this question, the field flux along the direct axis and armature MMF along the interpolar axis. So that option the 2 is correct for this question. And next one, question number 11. In DC generators on no load, the air gap flux distribution in the space. So air gap flux distribution in the space is sinusoidal, triangular, pulsating and the flat tapped wave. So shape of the flux distribution in the DC machine, suppose it is a flux distribution, it is a flat tapped wave. Okay, this one is this is north pole and this one is the south pole here. So it is the flux, okay, distribution. Okay, this one is flux distribution. So now with respect to the times, this one is this type of the wave is known as the flat, okay, tapped wave. So this is the flat tapped wave. Got it? So now answer for this question, option the 4 is correct. And next one, let us solve question number 12. The effect of armature reaction in the DC machine can be reduced by using option 1, commutating poles only, compensating winding only, the commutating poles and compensating winding, and the damper winding. The effect of armature reaction in the DC machine can be neutralized by using both compensating winding and commutating poles. And it is also called, another name of commutating poles is a interpoles or compoles. So this option, the 3 is correct for this question. And next let us solve question number 13. So in an 8-pole lap-wound DC generator has 720 armature conductors and braces are given a lead of the 2 mechanical degrees. If the full load current is 960 amps, calculate the demagnetizing ampere turns per pole. So we require, so this one, the demagnetizing ampere turns per pole. So these are the options, so for this question. So first one, let us see the given data. So what is given data in this question? The given that the number of the poles, P is equal to 8 number of the poles, and also mentioned that it is a lap connected armature winding, so that A is equal to P equal to 8 number of the poles. And how many number of conductors are mentioned here? So this one is a Z is equal to 720 conductors and braces is given a lead of 2 mechanical. So mechanical angle is equal to 2 degrees. But how do we get electrical angle? So from here we know electrical angle is equal to P by 2 the mechanical angle. So this electrical angle is equal to P is 8 by 2 multiplied by 2 degrees. So that, so this one is a, so here 4, so 8 degrees. So this is the electrical angle. And the full load current is, the current also mentioned, so that armature current is equal to the 960 amps. So now 960 amps. So we required demagnetizing ampere turns per pole. Okay, these are the demagnetizing ampere turns per pole. How do we get demagnetizing ampere turns per pole? The demagnetizing ampere turns per pole. What is the formula to find out the demagnetizing ampere turns per pole? So that is a 4 theta E divided by 360 degrees. The conductors, so this one is a IA ampere turns, IA by A multiplied by Z by 2P. So this is the formula to find out the demagnetizing ampere turns per pole. So now just substitute in this formula, the demagnetizing ampere turns per pole is equal to, so this is the 4 into 8 degrees divided by 360 degrees. Okay, it is a 2 degrees and 8 pole machine number lap connected. So now this is equal to 8 degrees and armature current, the 960 amps. Okay, this one is the 960 divided by 8 number of the poles, 8 number of parallel paths, and Z is equal to how many number of conductors? 720 conductors divided by 2 into 8. So now by solving this, so we will get 480 ampere turns. So answer for this question, the 480 ampere turns is the right answer for this question. Okay. So this was the discussion about previous year questions of Ecet in the concept of armature reaction and commutation. I hope you got it. Thank you very much.
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. అడ్మిషన్స్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.